Welcome back. Today we're talking about ions in our series on grade 10 chemistry. On the screen there is a little bit of a plan of sort of the loose sequence that we're running through. There is a little quiz that goes with today's particular activity that we'll get to at the end of the lesson. Let's get going. What are we going to look at? We're going to look at periodic table to predict the formula of an ion. Remember, an ion is just a charged particle. Because the atom has gained or lost electrons, it's become charged. Because the electrons it gains or loses are charged, hence we could call that an ion. Write some simple ionic formula. Look at polyatomic ions. Now think about it. Poly means many, atomic means atoms, so ions that have more than one atom. And where are we heading with all this? We should have looked at these textbook pages prior to today's lesson. Right, there's a video here I want you to go and check out. It's about valence electrons. So remember, valence electrons is the number of electrons in the outermost shell because they're the important ones for reactions. We don't care about the electrons in previous electron shells. Remember, the first shell takes 2, then they take 8 in every shell after that. It gets a bit more complex when you get into bigger bigger atoms, with more electrons. It doesn't follow that 2, 8, 8, 8 format. It eventually diverges a bit from that, but that's something you'll look at in more chemistry later on. So, the number of valence electrons is related to where an atom is on the periodic table and which group it actually belongs to, and that determines how it actually reacts. Check that video out, and then come back to this one. Right, discuss some of this. How many valence electrons are there in these atoms? So, we look at our periodic table. Hydrogen is that one there. It is in group 1, so it has 1 valence electron. Helium is over here. Now helium is a bit weird because it only has, its atomic number is 2, as you can see on the screen there. So it only has 2 electrons. So helium is a bit funny in that it only has 2, even though helium is in group 8. But that's about how stable these are. Previously, when we looked at the periodic table, group 8 was known as the noble gases because they didn't react, much like sort of in times when you had the common people and noble people. The nobles didn't sort of mix much with the commoners because they were kind of seen as better, that type of thing. Hence, noble gases, because they're all gases, don't react because they've already got a full outer shell. Helium's only got 2. The first shell only takes 2 electrons, hence its outer shell's full. Potassium's the next one. Potassium is that guy there. It is in group 1, just here like hydrogen, so it will have 1 valence electron. You can draw out its electron configuration and prove that it's got it, or you can just understand it's in group 1, hence it's got 1. Fluorine. Fluorine's over the side here. That's group 7, so he'll have 7 valence electrons. Now he's not going to lose 7 and become positively charged. Fluorine will gain 1 and become negatively charged. And sulfur is in the middle here, is in the next group over. That's group 6. So he has 6 valence electrons. Because as we run across group 2, group 3, group 4, group 5, group 6, and so on. And there, that corresponds to the numbers at the top of the columns there, or the groups. Okay, another video I want you to go and check out, which talks about the idea of anions and cations. A cation is a positively charged ion, and an anion is a negatively charged ion. That's all. It's just a term that we use. I kind of think of like cations as it's got like a T in the middle of it. T looks a little bit like a plus symbol, which is a positive sign, whereas anions has that N sound at the start of near the start of the word there, and N for negative. That's my way of remembering it. Come up with your own way. Just remember, cations are positive, anions are negative. Cations has a T in it, which is like a plus. Anion has that N sound for negative. So, following on for that other little video that I directed you to, things that we've got to think about. Why do ions form? Ions form because these elements want to become more stable. They are stable if they have a full outer electron shell. So they will gain or lose electrons to keep their outer shell full because that is stability for an atom. A cation is a positively charged ion and an anion is a negatively charged ion. So an anion is negatively charged, so it has more negative charges, so it must have gained an electron or some electrons. If a cation is positive, it must have lost them. It must have been, for example, oxidized. Using the periodic table, write some symbols for the ions formed by each of these. So lithium is right there. So its symbol is Li, as you can see. It is in group 1, hence it will have one valence electron that it'll lose, so it becomes positive. Beryllium's right next to it, that's in group 2, so he's going to lose 2 electrons, form 2 positive charges. Fluorine's right over the side, over there, his symbol's F, that's group 7, so it will gain 1 electron to have a full outer shell. So if it gains an electron, it gains a negative charge and becomes F minus, 1 negative charge. Sulfur. Now note how I wrote sulfur there. Often we write in Australia, probably a little bit more correct, with an F is a bit more of an American way of doing it. I left that in there just to show you that there's 2 different ways of writing sulfur, but in Australia we generally write the pH. So sulfur is right there. That is group 6 because it's the one right next to 7. Sulfur symbol is S. So if it has 6 valence electrons, we will gain 2, and in gaining 2, we get a full outer shell like the noble gases, and that is stable. So if we gain 2 electrons, that would be 2 negative charges. See how we're starting to write our ions? That's how we do it, just like we've done there. Right, let's look at some more examples. Might pay to have a look at how I do a few of these and then see if you can have a go at some. Sodium and oxygen are done for us. Calcium is there. So it's symbol Ca. That's the next one on the table. Symbol Ca. Atomic number is 20, as you can see on the periodic table down the bottom there, and it's written in the table. So if it's 20, that means it's got 20 protons, which means it has 20 negative charges, so 20 electrons, 2 in the first level, and then 8 in every level after that. So 2 plus 8 is 10, plus another 8 is 18, but I need to get to 20, so I have 2 in my outer shell. That means we will lose 2. If we lose 2 electrons, we're going to have a 2 positive charge, and the actual ion will look like, if you go back and look at your reactivity series that we looked at a couple of videos ago, you'll see why calcium was written that way when it became an ion. All right, chlorine. Chlorine's a gas over there, atomic number 17. You know it's in group 7, so it's going to have 7 electrons in its outer layer. It says its atomic number was 17, and chlorine is Cl, obviously. So 17 electrons, 2 plus 8 is 10, 7 left over in the next layer. So we will gain 1, so that will be 1 negative, 1 minus, so it will be Cl minus. Li is next, which is a lithium, right there. So that's symbols Li. Its atomic number is 3. We see from the periodic table. We have 2 electrons in the first level, and we only need 1 more to make the 3. So what will we do? We will lose 1 electron, which gives us a 1 plus charge, which is Li plus. Be is next, right next to him. Be is beryllium. So Be has an atomic number of 4. So we only have 1 extra electron from what we had before. So it's the same as the electron structure we had there. 2 in the first layer, 2 in the next layer. So we will lose 2 because there's 2 there, which is a 2 plus charge because we're losing 2 negative electrons. Be2 plus. When I'm drawing this configuration one here, I'm drawing those electron layers that I showed before. So beryllium, for example, has its first layer with 2 electrons. Those 2 that I've drawn are those 2 I've shown there. The next layer will have 2. So, for example, 1, 2. So those 2 represent those 2 there. You can see it's easy to lose these 2. The next layer then becomes full. It's easier to lose these 2 than it is to gain 1, 2, 3, 4, 5, 6. Is it easier to find 6 electrons or lose 2? It's easier to lose 2. Hence, this is the shell that becomes full as the outer layer, and that's how beryllium becomes stable. F, fluorine, 9 is the atomic number, so F, 9, so we need 2, then 8 goes in the next layer, but we don't need 8. We'll only need 7, because 2 plus 7 is our 9. So we have 7 electrons in our layer. If we just added one more, we would have that full outer shell. So if we gain 1 negative charge, that would be 1 minus. So that would be F minus. Goodness me, look at that F I drew there. And the last one is S, which is sulfur, 16 right there, group 6. Sulfur has 16, 2 in the first layer, 8 in the next layer, 2 plus 8 is 10. We only need to get to 16, so there would be 6 in the last layer. So if we have 6 electrons in our last layer, we need to get to 8 to fill that level. So the choice is, the difference between 6 and 8 is 2 electrons. So do we gain 2 or do we lose 6? What's easier to gain? 2. Gain 2, that would be 2 negative charges. Sulfur, 2 minus, is how we draw the actual ion. All right, and if you look at sulfur, 2 across is the noble gases, which is a full outer shell, which is stable. There's some more examples on the screen there. I encourage you to pause, have a look at those. When we get to atoms like carbon, they start to form a little bit differently. What you'll notice though is the ones that become positive charged tend to be on the left-hand side of the periodic table, and the ones that become negatively charged tend to be on the right-hand side of the periodic table. It just works out that way. Whereas in the middle, something like carbon has a different sort of structure and tends to bond a little bit differently. Because, for example, when sodium loses its electron and chlorine gains an electron, sodium becomes positive, chlorine becomes negative. This ion is attracted to this ion because it's exactly like having a positive and a negative charge, because that is that one and that is that one, and they stick together, which forms sodium chloride, which is table salt. This is the basis of ionic bonding, which is why we're talking about this stuff. Covalent bonding is a little bit different. Ionic bonding, it's like the electron is given up from the sodium to the chlorine. The chlorine keeps that extra electron. They both become charged and they stick together. That's ionic bonding. Covalent bonding is a bit different because the electrons are kind of shared between the atoms, but we're not looking at that at the moment. That's just a bit of a heads up on more chemistry. Okay, how many electrons have been gained or lost by the following? Phosphorus, P, has a 3 negative charge, so it has an extra 3 extra electrons, so that means it's gained 3. Oops, I can't spell. Gained 3 electrons. Br negative, so that's bromine, it has 1 negative charge, so it has gained 1 electron. Magnesium has a 2 plus charge, so because it's positive, it's lost negative charges, so lost 2 electrons. And iron has a 3+ charge. Fe is iron. Ferrous, iron. It's like a Latin term. It's got a 3+ charge. So here we have lost 3 electrons because it's lost 3 negative charges to give it a net 3 positive charge. Okay, a bit more work for you to go on with. Check out these pages of the textbook. Have a look at how some of these this work's put together. There is an ionic formula worksheet in the OneDrive, and the next few slides have a little bit out about ionic Sudoku you can have a look at. The idea of the polyatomic ions that we didn't discuss too much was we've been talking about single atoms. Sometimes these ions form with groups of atoms. So when we've past we've referred to things like copper nitrate or silver nitrate. The nitrate is nitrogen and oxygen group, which overall forms its own ion, as in the nitrogen and oxygen in the nitrate bond together and stick together, but the whole thing, when it's stuck together and bonded together, is charged, hence it is an ion, but because it's got more than one atom in it, that's what makes it a polyatomic ion. Okay, so there's some stuff there you can check out with the ionic Sudoku if you want to have a bit more of an extension task, where you get to sort of put some of these together. You get to work out how these different things can react in different ways. A little bit more complex, but I do recommend you go and complete this form. You have to do that one for today's lesson. Have a think about what we learned today, and next time we'll have more about writing compounds. Thanks for coming.